everyone, and welcome to our lesson on graphing basic exponential functions. You need to know that an exponential function is some function where we have a number base and then the variable is the exponent. So it looks something like this. So the base b can be any number. It can be a positive number. It can actually even be a negative number. It can be a decimal or a fraction. We're going to take a look at different kinds and what they look like. The two main types of these functions are growth and decay. So when you see that your function from left to right is increasing, that is a growth function, and when it's decreasing, that's going to be decay. And what's going to cause that is the base that we looked at, the base b. B is just any number, so when you see that b is bigger than 1, that is going to be your growth function. And I want to show you what that looks like on the graph. I'm going to sort of come in from the left-hand side, sort of riding on the x-axis, cross through 0, 1, should cross through here actually, and then continue and increase upward on the right-hand side. And then decay is going to do the opposite. It's going to come in, starting from left to right, it's going to be moving down, and then eventually close in on the x-axis. Sort of what they do here is they get closer and closer to the axis, but they never actually cross, and that's called an asymptote. That's an invisible boundary that they'll never cross, but they're slowly approaching closer and closer. Alright, so the decay functions have their base between 0 and 1, so that's going to be usually your fractions and your decimals. Just be on the lookout for that, and also be on the lookout for tricky things that they'll throw in to make you think that one is growth or decay. For instance, here are some examples of growth. We can see the top one has a base of 3, so we know that's growth. It's bigger than 1. This middle one here, your mind would first go to the thought, oh, decay, because I see a fraction. But it's actually has a value bigger than 1. If you look at this fraction, 8/7, that's bigger than 1. That's 1 and 1/7. So that's still going to be growth. And then down here at the bottom, we've got 5.2, still bigger than 1, so it should have that increasing picture, that growth picture. Over here on the right-hand side, you can see some examples of decay. We've got 1/5, that's less than 1, but bigger than 0, so that's decay. Same thing here in the middle, 6/10, and same thing at the bottom. Just want to show you a variety of examples of different kinds of growth and decay that you may see. Alright, so I kind of showed you the general picture of the growth and decay functions. We're going to take a look at this specific example and show you how to graph these when you come across them. Basically, what you're going to do is, if you do not have a graphing calculator, you're going to come in and make an XY chart, and you'll just plug in X values to test them in the function and then calculate out to the matching Y values. So you can use something on both sides of the middle y-axis line to get a good picture. You may want to use 0, maybe -1, and maybe +1 to start. See if that gives you a good general shape. So when I plug in 0 here for my exponent, anything to the 0 power is 1. So 2 to the 0 is 1. When I plug in -1, that's going to give me 1/2 to the +1, which is 1/2. You can get that by typing it in or knowing those exponent rules about moving the base. And then when I plug in +1, 2 to the 1, that's just going to give me 2. So you want to go graph these points and then connect and see what kind of picture we have. So 0, 1 we have here, -1, 1/2, and 1, 2, and you could continue to test more on the negative side or the positive side, but you can see the general shape. We'll get a different color and connect here. Going to be growth, going to be coming in something like this. And I do want to mention that no matter what your base number is here, we have a 2, but no matter what you see there, as long as it's positive, the y-intercept is always going to be 0, 1, and that is for the reason that we just discussed, that any number to the power of 0 is 1. So it should always cross through here unless it's had some kind of negative attached to the front and been reflected. All right, let's take a look at our second example, and this will be a decay example because we look at our base here before we even test points and we can see that it's between 0 and 1, so that means we're going to get a decrease picture, a decay picture. We can test the same values that we did before. We can try some different numbers. We could do 0 again. We can do positive 1, negative 1. We could do maybe 2 and a negative 2. Let's do that to get a really nice picture here. All right, so 0, anything to the 0, we said is going to be 1, so that will not change. Go ahead and plot that. 1 is just going to give me the same number, 1/3. So 1 1/3, we can plot that point. Negative 1 is going to give me a value of 3. I'm going to take the reciprocal because of that exponent rule. 3 to the 1, which is 3. Go ahead and plot that point. All right, 2 is going to give me 1/9. So that's really getting small over here on the right-hand side. It's coming in towards the x-axis, but remember it's never going to cross it. And then negative 2 will give me positive 9. 2, 3, 4, 5, 8. Count up to 9, and we've got it. So we're just going to connect these. Remember, it's going to come in and right on x-axis where the asymptote occurs. There's our exponential decay function of 1/3 to the x. All right, so on the opening slide, we talked about that b can be any number, positive, even negatives. The one number that it cannot ever be, however, is 1. That is a domain restriction on this type of function. And I wanted to talk about why that is. If you think about when we tested our points for our exponential functions, if it were a 1, if it was 1 to the x, and we started testing some points here, let's say 0, and maybe a 2, maybe a negative 1, any kind of positive or negative numbers. 1 to the 0, remember anything to the 0 power is 1. 1 to the power of 2, I'm just multiplying 1 by itself twice, so I'm still going to get a 1. If I put in a negative 1, I will have 1/1, which is still 1. So you can see what's happening here. Every value you try, you are going to get the result of a 1. So what happens in that situation on the graph is that you just really get a straight line all the way through, continuing on to infinity through the number 1. So it's no longer an exponential picture. It's not increasing or decreasing. It's just a constant line. So that is why the base cannot be 1. But it can be any other number. And just remember that a negative in front is going to cause that graph to reflect. So this concludes our lesson on graphing basic exponential functions.